Hello everybody, today in Engineering Statics we're going over question 2-43 from the Hebler Statics textbook, so let's get right into this. Determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. So first off, let's dissect the last bit of that. Counterclockwise from the positive x-axis. Direction, so the angle. Basically this is the positive x-axis right here to the right of the origin. Positive y is above the origin, and basically the easiest way to tell is wherever they put the ladder, wherever they put the y and wherever they put the x, that's the positive direction. Counterclockwise is in this direction right here. You can look at your clock if you don't believe me. That's counterclockwise. This is the positive x-axis, therefore that's going to be what our angle kind of looks like. So let's say F3 was our force resultant. Basically you just add 45 degrees here, so 45 plus the total amount of angle in this this section here, so 90 degrees, and that's going to come out to 135 total degrees between this quadrant and this angle right here. Then there's the whole thing about finding the resultant force. Basically, to solve a force system like this, to solve for the resultant force, you need to sum each force by its x and y components. So for instance, let's look at F1. This would be its x component right here, parallel with the x-axis, so something like that. Then our y component would look something like this. And then when you add those together, so this would be our Fy, this would be our F in the x direction. When you sum these together, you get your total F, your F1, the hypotenuse. So that's what we're going to do for all these. We're going to break them all into our Fx's and our Fy's. We're going to add all their Fx's. Then we're going to add all their Fy's individually, separate from one another. The Fx's and Fy's, I mean. And then once we're done with that, we're going to add them together to come out with our equal, like in this case, our F1, except for it's going to be the total of all of these, which is going to be our force resultant. So let's get right into that. Then we can find the angle nonsense, which is quite easy. This is the hardest part of these questions. So the force in the x direction, let's start with F1, 850 newtons. That's positive, it's pointing towards the positive direction. And basically to find the ratio here, to find the x component, we're going to use this as our reference angle. And I'm going to need you to remember something from high school real quick. It's going to be SOHCAHTOA. So sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and then tangent equal to opposite over adjacent, although we don't need that in this situation. But we will to find the angle, so stay tuned. We're going to want to use cosine here, and I'll show you why. We have the angle between the x-axis and our force. We're trying to solve our x component. When you have the angle touching the component you want to solve for, that's when you use cosine. When you don't, that's when you use sine. So if you don't understand quite yet, you will, believe me. So in this case, we want to use cosine. So adjacent over hypotenuse, so 4 over 5 on our little triangle down here. 4 is our adjacent, 5 is our hypotenuse. And then we're going to want to subtract 625 because that's away from the positive x-axis, going the opposite direction. And to use this ratio, because we have 30 degrees right here between our force and the y-axis, and we're trying to find the x component, we will use sine because the angle is touching the wrong axis. If we were to use cosine, we'd have 60 here, and we'd use cosine of 60. This angle is touching the x-axis when we're trying to find the x component, therefore we use cosine. This angle is touching the y-axis when we're trying to find the x component, therefore we use sine. And we're going to use all the givens in this one because it's good practice, and using the givens makes it go much faster, much faster. So 750 newtons. And then just like down here, we're going to want to use sine because our angle is touching the wrong axis. Even though technically you could use either one for that because it's 45 degrees, so they're both going to come out the same. But our total answer for that is going to be 162.83 newtons. Moving on to the forces in the y, we're going to do the same thing. So for our F1 this time, we have the same angle here, right? Let me write down the force first. Always write down the force. It's basically just a force, and then you multiply each force by its unit vector, aka I just call it a ratio because you're trying to find either its y or x component using a ratio, basically. So 850 newtons here. We're going to use the same angle, so it's between our force and the x. We're trying to find the y this time. Therefore, we want sine. So it's going to be opposite over hypotenuse. So it's going to be 3 over 5. The side opposite of our angle, right? So the 3 over the 5 because it's hypotenuse. And that's going to be negative because it's pointing downwards away from the positive x. The next one's the same scenario, 625 newtons. And this one is going to be cosine of 30 because now we have our angle between our force and the y-axis when we're trying to solve the y component. Therefore, it's cosine. So cosine of 30 here. Then we're going to want to add our 750 newtons because that's pointing upwards towards our positive. Oh, excuse me. Oh, that's bad. No. Don't take after me. And that's going to be, again, cosine of 45 because it's touching our y component and it's the angle between them, and we're trying to solve for the y. So then our forces in the y, these are the sums, by the way, so you might want to put a sum symbol or some sort of indication, or forces in the y are. And then that's going to be negative 521 newtons. Now we need to add them. But before we add them and find our force resultant, I'm going to show you what these look like. So negative 162, so that's going to be something like this, right? Negative direction in the x-axis. You can think of that as our y coordinates because that's basically what it is. And then our x coordinates, then our y coordinates are going to be something like this. Connect these together. It's going to look very similar to F2. So this is our fx we found, our total fx, and this is our total fy right here. Then this is our fr, the hypotenuse. So all we need to do is add these together. This right here is a 90 degree. This is a right angle triangle. And like a lot of us know here, we have both sides. We need to find the hypotenuse in a right angle triangle. Therefore, it's as simple as using the Pythagorean theorem. So let's get right to it. So the Pythagorean theorem, as we all remember, c squared, in this case fr squared, because c squared is our hypotenuse, equals a squared plus b squared. And in this case, those are the other two sides. In this case, it's going to be fx squared plus fy squared. Now we need to get rid of our square over here by square rooting it. Square root this side. Now we have our fr is equal to all of this stuff in our nice little square root. So it's going to be fx 162.83 newtons squared plus 521 newtons squared. Our force in the r, the total for that guy, it's going to come out to be 545.85 newtons. You might be wondering where the negative signs go. Well, when you square root a negative, it's a negative multiplied by a negative because you're multiplying the number by itself. Therefore, we get a positive. And the second reason to do this, to just leave the negative out altogether, is because most calculators, a significant amount of calculators, do not account for that negative, which could give you the wrong answer. Even though a negative squared is supposed to be positive, it leaves it as a negative, which could be a problem. So let's just disregard that and just turn it positive beforehand, and you'll avoid issues. So that's our first answer. Now we need to find the angle from the positive x-axis, so something like this guy right here. We know this already, right? Because our force is all the way down here. We know it's going to be over 180 degrees because this right here is already over 180 degrees. Each quadrant's 90, or you can think of it as a half circle is 180, and each quadrant's 90, and we have two quadrants. So this is going to be 180 degrees right here, right? So we already know our theta resultant is going to be over 180. So now we need to solve this and add 180 to it. We need to solve this angle right inside here, right inside the triangle. So to do that, we're going to use actually tangent opposite adjacent, except for slightly rearranged. So it's going to be tangent inverse, rise over run, opposite over adjacent, or in this case, fy over fx. Force in the y, so that's our rise, and then force in the x, and that's our run. So tangent inverse, aka our theta, is going to be fy 521 newtons. And you can leave the negatives out or keep the negatives in. You know what you're solving for, and it's always going to be positive. And then for an answer for that, we're going to get our theta. This is all equal to theta. Theta equals 72.6 degrees. Now to find our theta r, all we do is add the 180 degrees, which we know come from these two quadrants up here, and then add our 72.6 degrees from the inside of our triangle. From that, we're going to get 252.6 degrees. And those are our two answers, and we have solved the problem. I really hope this helped you. Please like and subscribe. And most of all, the most important thing is to have an awesome day. Thank you for watching.